Hi guys. In this video, we're working on solving systems of linear inequalities. So linear because it's lines, inequalities because we have to shade regions. Let's see what we have here. So when we look at the first graph, we have three linear inequalities. One that goes from side to side, a horizontal line going through right there at one with positive slope, solid line, shaded above, and the other one with negative slope, also shaded above. So you have different colors right there. So in this one, you can, still on number one, the first graph, you notice that we have the green shaded region, the blue shaded region, and the red shaded region. And they all overlap in this part right here. Let me see if I can highlight it for you. So in this part right here, all three of them are overlapping right there. All three of them. The green, the blue, and the red. And it keeps on going forever that way. So what that means is anything on that region where all three inequalities overlap, that's part of your answer. It could be a point here, a point here, a point here, any point. Oh, even at this point right here on the line, it's also part of the answer. Just be careful, not on the dotted line. That is not part of the answer. Okay, but even if it's a fraction right there in the middle, they're all parts of the answer. Now on the second graph, we also have three linear inequalities. Right there, shaded below, right here shaded above, and this one shaded below. But notice that nowhere over there we have a region where all three inequalities overlap. This one only overlaps between the green and the red, this one between the green and the blue, this one between the blue and the red. So nowhere over here all three of them overlap. Okay, so that means no region over there, nowhere on the graph, you would be able to find a point that is part of a solution. So this one has no solution to your system of inequalities. So explain what the different shaded regions and the unshaded regions represent. I'm just giving words for everything that we just talked about. So shaded regions are areas of the graph that are included in the inequality. And that's what this shaded region was. All three inequalities overlap right there. And the unshaded are not included in the inequality. Pretty simple. What is the solution to each system of inequalities? We talked about how anything on that shaded region where all three of them overlap, that's part of your solution. So any point that lives in that shaded region right there, in that shaded area of all three inequalities. And we already talked about this. Second graph has no solution. Do all systems of three inequalities have a solution? Explain your reasoning. No. And second graph is a perfect example of that. Sometimes they will not cover the same portions of the graph. Okay? Now this is page 2. So now we're going to test them out. We're going to choose a point from the graph anywhere that we think there might be a solution to the system. And from the previous page, we know it should be the area where all three of them overlap. And the area that all three overlap will be this region right here. This region right here. Okay, so I'm just going to choose a random point that is going to be easy for me. I don't know, 1, 1, that one. So I'm going to choose 1, 1. How can you check that point you picked is a solution given the inequalities? So here, these inequalities are graphed right there. So it's one last thing we need to do. It's already graphed. But we're going to test. So I'm going to plug in and substitute. Let me choose a different point then. Let's do 2, 1. That is right there on the line. It's a little questionable. Let's do 3, 1. That's not in the region. I wanted to use two different numbers. Let's do 1, 2. I could make up my mind on that. You can tell that this has not been planned. Haha. Okay. The reason why I chose to do 1, 2, not 1, 1 was just for teaching purposes, because when I'm plugging in 1, 1, you don't know which one I'm plugging it in. So that way, you know, when I'm plugging in 1, you know it's X. When I'm plugging in 2, you know it's Y. So I'm not doing 1, 1 just for the sole purpose of just easier for you to follow along with me and understand the teaching behind this. But if you want to go ahead and test 1, 1 just to do work, that's fine too. Either one would work out. Okay, I'm going to test out in the first, second, and third. So, and they all must come out to be true statements in order for that point to be part of the solution. So I'm going to test out in the first inequality. I have y is less than or equal to x plus 1. Go ahead and substitute 2 for y and 1 for x. So 2 is less than or equal to 3. Is that true? Yes, that is true. Let's move on to the second one. So second inequality, y is greater than or equal x minus 1. Substitute 2 for y, 1 for x. Is 2 greater than or equal 0? Yes, it is true. True is definitely, 2 is definitely greater than 0. So the third inequality, I have y is less than 4x. Substitute 2 for y and 1 for x. Is 2 less than 4? Yes. They're all true. Therefore, this point belongs to that solution, to that region where you believe to be the solution to your system of inequalities. I'll make another video for the next questions.